Hello everyone, and I am Abhijit. Today in the screencast we are going to discuss about streamlines, straight lines and path lines. All these concepts are related to something which is called as flow visualization. Flow visualization is a method in which we visually observe the flow and how it is behaving. In many engineering problems, it is difficult to predict the behavior of the flow purely on the theoretical background, and it becomes necessary to visually observe the flow. One of such examples is designing of component which is called as a diffuser. A diffuser is nothing but a simple component, like this is a pipeline suppose, and this is another pipeline of larger diameter. So a diffuser is nothing but a component which is used to recover the pressure in the pipeline. So for designing this diffuser, it is important that when the flow passes from section 1 to 2, how the flow behaves, whether it sticks completely to the surface or whether it leaves the boundary. If at all it leaves the boundary, then when it is leaving the boundary, what is the direction of the velocity profiles at all the sections. All these things are difficult to be predicted purely on the theoretical background, so we have to visually observe this flows and take decisions. That's why we go for flow visualization. Now first we will see the concept of path line. I'll just erase this. So what is a path line? A path line is nothing but the path traced by a fluid particle over some period of time. So suppose you are having a particle like this, and over some period of time it has traveled here, then the path which is traced by this particle over a period of time will be termed as a path line. Next is your streak lines. Streak lines. Now streak lines are instantaneous phenomena. At any instant, a streak line is the locus of the subsequent particles passing through a fixed point. In order to elaborate this, we will consider a flow past an object. Suppose this is an object. This is an object, suppose. And flow is taking place from left to right around this object. And we are suppose injecting some dye here in front of this object like this. And particles are flowing like this. So first particle, now at any instant t, right now suppose the first particle which came out of this injector came here, second particle was here, third was here, fourth was here, fifth was here, suppose. Then at any instant the locus of all these points will give us the streak line. Now the third concept is the concept of streamlines. Streamlines. Streamlines are also an instantaneous phenomena. At any instant, streamlines are the curves such that if you draw the tangent to the curves, then it will represent the velocity vectors at that point. So suppose at any instant t, these are the streamlines. These are the streamlines, suppose. Then if we draw tangent to this streamlines, so this is a tangent, this is a tangent, again this will be a tangent. So this tangents, again here I will draw a tangent, here I will draw a tangent. Okay, so these tangents will represent the direction of the velocity vector at that instant. Now it is quite obvious that two streamlines cannot cross each other in any kind of flow, because it will violate our basic idea that suppose two streamlines are crossing, it means that at single point there will be two velocity vectors at the same instant, which is not possible and violates the idea. So two streamlines can never cross each other, no matter how the flow is. It may be steady, it may be unsteady, still it might not cross each other. On the other hand, path lines may cross each other, but streamlines cannot cross each other. Now we will try to write an equation of streamline. For that purpose, we will consider a three-dimensional flow. Suppose a three-dimensional flow in x, y and z axis, suppose, and this is a point, and these are the streamlines. Suppose they are the streamlines, and we will consider one point. I'll change the color. Suppose at this point we will consider the velocity vector. Now it should be tangent to the streamline. So let the coordinates of this point be x, y and z. Now if we consider a very small time dt, then the displacement vector would also be in the same direction, ds. So if we take the cross product of both, what we would get, the cross product of velocity vector, the cross product of displacement vector would be 0, because both are vectors and the cross product of two vectors in the same direction would be 0. The velocity vector can be written as, the velocity vector v can be written as I u plus j v plus k w, where I, j, k are the unit vectors. Suppose I, j and k are the unit vectors in x, y and z directions. So similarly you can write the vector ds, displacement vector ds, as I dx plus j dy plus k dz. So if we take the cross product, then you can write in the determinant form in this way. So we can write like this: determinant of I, j, k, u, v, w and dx, dy and dz. This determinant should be equal to 0. U, v, w are the velocities in x, y and z directions, which you can easily guess. So if we solve the determinant, we would get u dy minus v dx is equal to 0 and u dz minus w dx is equal to 0. Also, we would get v dz minus w dy is equal to 0. If we solve all these equations, it's very simple that you would get something, an equation like this. Say from the first equation we would get u dy is equal to v dx. So from first equation we would get u dy is equal to v dx. So you can write, therefore we can write u by dx is equal to v by dy, and similarly from the third equation we would get w by dz. So this is nothing but the equation of your streamline in 3 dimensions. So here we see a flow visualization method in which a DC current is passed through a conductor and it is inserted into water. So due to the electrolysis, hydrogen bubbles are created, and these bubbles will flow along with the water. Here you can see multiple probes which can be used for visualizing these hydrogen bubbles through electrolysis. We can also create bands of hydrogen bubbles. All this can be extremely useful for flow visualization. Now here what we are going to do is we will see and observe a flow through a contraction and define what is a streamline and what are the streak lines. So here the flow is taking place from left to right. What you can see is a particle of fluid which is flowing from the larger area to the smaller area. Now the path traced by this particle over a period of time will be termed as the path line. As we can see here, the path line is clearly visible. Alternatively, we can continuously inject hydrogen bubbles at a fixed point and see the behavior of the flow. This particular line at any instant, which gives the locus of the subsequent points passing through a fixed point, is called as a streak line. So here what you are observing is a streak line. An example of streak line is smoke coming out of the chimney. It can be an example of a streak line. Now for a steady flow, like in this case the flow is a steady flow, what we can observe is that the path line and streak line coincide with each other. These are the multiple streak lines. Another concept is what is used is called as a timeline. What we are seeing here is a timeline. It is just the locus of path of particles which are 90 degrees to the flow. A path line at any location would give us the velocity profile at that particular location. Such path lines are extremely useful for analyzing the flows in which the velocity gradients are extremely important. Like in this case, the flow is taking place over an airfoil or a wing of an airplane. What we can observe is that the timeline on the top of the airfoil and as well as the bottom of the airfoil is meeting the tail end at nearly the same point, which shows that velocities at the top and the velocities at the bottom of velocities above and below the airfoil are one and the same. So no lift in this case will be generated as per the Bernoulli's principle. But in this case, if you observe for some positive angle of attack, what we can see is on the top of the airfoil, the timeline is moving ahead of the timeline which is below the airfoil. It means that the velocities at the top would be higher than the velocities at the bottom. Opposite is happening in this case. Here we are observing a unsteady flow because in this case the flow is taking place around a plate which is oscillating. Let us try to observe some characteristics of this flow. Here we are seeing a particle which is moving in this flow. So this path traced by this particle will be the path line. Again we can see the path line here. Now if we see the instantaneous streak lines passing through the same point, we observe that none of the streak lines is coinciding with the path line. Try to see, it is not at all coinciding with the path line. So for unsteady flows, the path line and streak lines are not the same. Again, we are trying to study the path line of particle entering at some other point of time in this flow. So as you can see here, these are the two path lines of points which can be in this flow. Again, if you observe the streak line passing through the same point, then we will observe that none of the streak lines is coinciding with any of the path lines. Now let us try to find out a streamline and let us see whether it coincides with any of them or not. So for the purpose for doing the same, we will superimpose two transparencies within a short interval of time and try to find out the velocity vectors. So this is at one instant of time and this is at some another instant of time. So if we can draw the vectors here, the displacement vectors, the velocity vectors would look like the same. Now if we draw curves such that these vectors are tangent to these curves, then we would get the streamline pattern. So we will do the same here and what we will get would be a streamline pattern. Now again, if we observe the streamlines or the streamline pattern, will it coincide with the path line or streak line? That we will just see. Now this line which you are seeing is a streamline, and what we observe is the path line and streamline are again not the same. If we see the streak lines, still they are not coinciding with the streamlines. So it means that whenever we are observing a flow, if the flow is unsteady, what we observe by visualize is actually the streak lines, and in case of an unsteady flow, the streak lines, streamlines and path lines are all different. Thank you.